Channel control allows you to have many sensors, like many eyes, all watching different points of your structure. Multi-channel vibration control is applied when the user needs more than one control channel, since one sensor cannot detect how a large and complex structure vibrates. To receive data, it is necessary to install many sensors on a large object. Multiple control channels increase precision, safety, and quality of the results. In fact, there are no major differences here from the general objectives of vibration testing. Multi-channel control answers the same questions as: does my product survive the vibration it will face in the real world? And where are the weak points, the resonances, and the hidden failures? Multi-channel control helps you to verify that products meet the standards and specifications they were designed to, determine the vibration resistance limits of the entire object, not just one corner. It helps you also to understand how the structure behaves when excited at its own frequencies, explore dynamic characteristics, and identify mechanical defects or degradation before they become failures. And if testing of the object is required using multiple shakers in one or multiple axes, then we conduct multi-channel, multi-shaker testing using multiple outputs and multiple inputs of the system for closed-loop control. Now let's present the brand new vibration control and data acquisition system manufactured by Ruler Technologies. It is RL-C25M, and it is the next evolution of our advanced RL-C25 system. We listened to what engineers like you were telling us about setup difficulties, synchronization struggles, the limits of older hardware, and we designed a system that removes those barriers. The system was designed to solve a wide range of tasks, like data recording and analysis, vibration tests of complex objects, model analysis, static and dynamic tests using vibration, strain gauge, pressure, and temperature data. So now let's look at what it delivers. Um, One controller can have up to 72 measuring channels and up to 4 output channels. And if we talk about the previous version, RLC25, it could have maximally up to 24 inputs.
And I think, correct for a second, the maximum number of output is not 4, but 8 per controller, right?
Yeah,
Yeah, 8.
yes, sorry. So what does it mean for you as a user? It means you can now replace 3 racks of equipment with one box. 3 controllers meant 3 sets of cables, 3 power supplies, 3 synchronization headaches. Now you have one system and one connection. And if 72 channels aren't enough, well, then the system scales. It can be scaled up to 1024 channels in a fully synchronized data acquisition set. By the way, we have increased the maximum synchronization cable length to 80 meters, and this is especially useful when testing large-scale objects. So when one module stays near the test object and another in the control room. So let's go next.
Yeah, I think maybe it's also worth mentioning that the frequency range stays extremely wide, yeah, as well as the dynamic range. So we still deliver DC to 106,000 hertz frequency range, which covers the fullest range of vibration tests and allows for the full vibration test functionality. And another thing is sensor types. So here we don't just do accelerometers of various types, but we also can connect displacement sensors, force center sensors, and we have dedicated strain gauge modules, which you will mention on this, right?
Yeah, and also I wanted to add that if we talk about the hardware structure, then we must highlight that there are 3 available variants of modules. So you can choose by yourself for 8 input channels, 8 strain gauge channels, and 4 output channels. You can mix and match to build exactly the configuration your test requires. Um, Now about the strain gauge mode.
Yes, we can talk about it because specifically for MISO, yeah, for multi-input configuration, very often strain gauges are essential.
So the system has 8 measuring channels for strain measurement. The voltage setting range of the resistive bridge is from zero point 0.5 up to 10 volt. This voltage drives the bridge circuit. The output signal of the sensor is directly proportional to the supply voltage. The possibility of choosing a higher voltage allows you to increase the sensitivity of measurements, but the accuracy of its installation is of key importance since all calculations are carried out relative to the reference level. Next, let me tell you about the absolute accuracy of output DC voltage and AC voltage on 1000 Hertz. So it is no more than 1%, and it guarantees high reliability of strain gauge measurement results.
Yeah, so we are showing here some key characteristics. You can study them on your own. You can ask questions if you're interested. I think it's also worth mentioning that just like our previous controllers, this one has a built-in charge amplifier, which makes the sensor compatible with piezoelectric sensors, converting charge into voltage. So yeah, that's also an important point. Um, yeah, okay. We've mentioned strain gauges. Is there any other key hardware characteristics that you'd like to outline?
Yes, I would like to outline the charge range of amplitude values. So it is plus minus 1000 and plus minus 10,000 picocoulomb. And the wider this range is, the more shocks you can measure. So the choice of a range up to plus minus 10,000 picocoulomb ensures that the system can handle the measurements of both low vibrations and intense shock pulses without data loss and the need for hardware reconfiguration.
How about the power supply, the voltage characteristics?
Yes, so if we talk about the system power supply parameters, then um, there are two options available. So for AC voltage, it is from 110 up to 245 volt, and if we talk about DC, then from 47 to 63 hertz. And this means that the equipment operates anywhere in the world without using additional converters and adapters. So the system works equally stable both in countries with a voltage of 110 volt and 60 hertz in such countries as USA, Canada, Japan, Taiwan, and in regions with a voltage of 220, 230 volts, 50 hertz in countries like China, India, Australia, and in European countries. And this wide frequency range allows the device to be connected to both stationary industrial networks and mobile generators, for example, during field tests in remote areas.
So yeah, this is very important that actually it goes to the clients worldwide without very smoothly without any extra difficulties. And I also would like to ask about whether it is rack mounted. Can it be rack mounted?
Yes, our system is available in both desktop and 19-inch rack mounted versions. The desktop version is ideal for laboratory research and educational institutions where mobility and compactness are important. And the rack mount version is designed for integration into stationary measuring systems and automated test benches where centralized equipment placement is required. Now let's move on to the compatibility with our software. So RL-C25M is compatible with both Ruler software with Signal Up, which was designed for data analysis, and with Test Up, which was designed for vibration control. Um,
Yeah, so just like all of our hardware platforms, RC21, 21M, RC25, and this newest RC25M, they're all compatible with our software packages. So the transition from one controller to another is absolutely smooth. And we have a number of videos and webinars covering the functionality of vibration testing and test up and signal up as well. So today we won't be stopping on test types in detail, but I think we will try to cover what is often in demand for those testing large structures, full vehicle bodies. We will stop a little bit on the question of modal analysis, which is one of the modules of SignalUp.
Yes, so one of the modules of SignalUp is experimental model analysis, and RLC25M multi-channel modular system allow collecting data up to 1024 channels. And using this software to perform calculations, you can determine the modal characteristics of an object, such as natural frequencies, the shape of natural vibrations of the structure. It is possible to process two types of data. So the first one is recordings of control and response signals during the excitation by random. And the second one is recordings taken from the frequency response object during the excitation by sine. The experimental model analysis in SignalUp provides vibrational excitation of the test object and collection of response data at control points, calculation of frequency characteristics, search and calculation of vibrational mode parameters, construction of a geometric model of the test object, and visualization of the test object at the found frequencies.
Mhm. And we will have a couple of case studies, and we wanted to start with a case study from the aerospace sphere, because I think I will not be wrong if I say that aerospace has the most demand for multi-channel vibration testing and data acquisition. So we've decided that we are going to talk about this application first and foremost.
So let me share a project that really showcases the power of the RLC25M. Let's open a Signal up. Second. Mm, share screen. Mhm. So now I suppose you can see the module uh, of the UAV, which was developed for fire detection. For the test, we hung the model on elastic cords inside a special frame, and this way we created conditions as close to free flight as possible. First thing, we connected a modal shaker, and next we connected the amplifier RL-A 500, which operates in current mode. And if we talk about model testing, this is this is critically important feature for amplifiers to have a current mode. At the bottom of the model, we mounted one force sensor, so you can see it here. This is the force sensor we had. On the fuselage, we mounted triaxial lightweight sensors, which measured acceleration along three axes. So, and here there are lots of them. So all of these sensors are triaxials. And on the wings, we installed strain gauge sensors to monitor deformation, and here they are named as Tenzo. Mhm. And the main question we needed to answer, what are the fuselage's natural frequencies? And these frequencies must not coincide with the engine's cruise revolutions per minute. Otherwise, the engine will start resonating with the structure, and in flight, this could lead to failure and damage. And based on the test results, the design was adjusted so that the natural frequencies stay clear of the engine's operating range. And as a result, the UAV flies stably and safely. Now we will go back to the presentation. Oops. And we would like to highlight another case study. So the leading company that develops automatic control systems for naval vessels contacted Ruler, and they asked for support across the entire life cycle of their projects, from scientific research and design to manufacturing and testing. Their portfolio includes submarines, surface ships, nuclear icebreakers, civilian vessels, and deep-sea vehicles. And
Yeah, for this one, we cannot really share the details of what we did, but just as an overview, we wanted to show that this is not just for aerospace, there are also a number of other applications in other spheres, like naval, for example. We will just say that we provided the measurement system for data collection for the sea trials and factory acceptance tests.
now we will go to test up and discuss the control strategies. Well, because when it comes to multi-channel vibration control, um, it is really important to choose the control strategy and
Yeah, because this way you will be able to optimize deviations from the task and reduce the vibration level on the object. So um, this choice, we hope that this choice is conscious and that uh, the user understands these differences and the advantages and disadvantages of each control strategy. That's why we decided to include this particular point to this presentation.
So in test tab software, there are three ways to set the control strategy: by average based on weight coefficients, by maximum, and by minimum. And let me tell you the difference between these three control strategies. So if you choose by average based on weight coefficients, in this case, each channel is assigned a coefficient, and the resulting signal is calculated as the sum of the channel values multiplied by their weights divided by the sum of the weights. So this allows flexible consideration of each sensory's contribution to the overall control signal. If you choose by maximum, so then the highest value among all channels is selected. And in this case, the control signal corresponds to the channel with the maximum amplitude, while all other channels show values below this level. And by minimum control strategy, so if you choose it, then the lowest value among all channels is selected, and the control signal corresponds to the channel with the minimum amplitude, while all other channels show values about this level. So now we need to open signal or to open test up.
Yes, and while we are waiting, I just wanted to point out that for now, this control strategy choice is available for sine, random shock, shock response spectrum, TTH, so transient time history, and superimposed tests like sign on random, random on random. So basically, for those that are the most common and the most widely applicable in necessary tests.
Thank you, Lina. So the program is loading. Mhm. So now we will choose Sign Test and open Test Settings. Here we need to open Channels tab. So, and in the bottom, you will see the control strategy. So all three we have already discussed, and you can choose the one that you need. And we understand that when users see the system for the first time, they can be overwhelmed with a large table of 72 channels or even more. Yes. Um, so, and this is why we decided to make your work as efficient and comfortable as possible and implemented a feature to set channels type. So here you can set the type you need. For example, all channels can be disabled or measuring. So let's set all measuring sensors. And you can see that here the type was changed. And uh, while all 72 channels are capable of working as control channels, in practice, most tests require only a few of them. Typically, 5 or 6 channels are used as control channels. Today, we have chosen 3 channels as control. Um, the remaining channels operate in measuring mode and they don't control the test, but they record data and provide full visibility of the system's behavior at every measurement point.
I think it's also essential to outline again that all 72 of the master device are capable of being control channels. So sometimes it's super crucial for a complicated structure.
So now let's discuss protection features. I'm going to go back to the presentation. We will stay in the software and discuss it here. So as you have a complicated object, which parts can have multiple resonances on its parts, you can easily damage it during the test run. And to avoid it, there are multiple additional options such as individual limits, notching limits, open channels control. These 3 were for sign test and filtering for shock test. So let's begin with the individual limit. You can see it here in the channels tab. So for example, we look at the channel 1 and here you can see individual channel limit. You can put a tick here. And you can define a deviation level in decibels, for example, plus minus 6 decibel. So let's put it here. The limit applies across the entire frequency range. If the signal on a channel goes outside the set boundaries, the control system immediately aborts the test. The limits can be set when controlling by acceleration and monitoring by force, for example, and for limiting mechanical loads on the shaker or test object, or to protect equipment from damage during abnormal operating conditions. Test limits are typically displayed as red lines on the graph. You can see them here. And these limits establish upper and lower boundaries that the signal must stay within. Dots on the graph, which you can see, indicate previously identified resonance frequencies. If we click on Limits tab, here we will find a Notch Limits sub-tab in the bottom. So let's click at it. And each channel can have both upper and lower notch limits. During sign testing, several types of notch limits are available. So let's look at them. In the channel 1, you can see a variety of notch limits. So limit at, limit decibel, limit table, abort at, abort decibel, abort table. The same is available for the upper limit. Now let's talk a little bit more about every one of them. So limit at allows you to set a specific value of a physical quantity such as acceleration or displacement. And when the signal crosses this threshold from below or above, the control system automatically reduces the drive level to keep it within the limit. So for example, you can set 6G here and 6G at upper level. Limit decibel sets a decibel limit, such as 6 decibel, ensuring the channel does not exceed that level. Limit table lets you define a limit profile using a table similar to the sign reference profile with the frequency-dependent limit values. So let's look how it works. So you can open this table and set here the start frequency, start amplitude, end frequency, and end amplitude. Abort at specifies a threshold at which the test is immediately stopped. Abort decibel sets a decibel-based abort threshold, for example 6 decibel, triggering an immediate test stop if exceeded. Abort table defines a frequency-dependent abort profile using a table, stopping the test if the signal crosses the specified values at any frequency. Next, we would like to pay your attention to the settings of open channels. So this feature was originally developed for an aerospace customer, a satellite manufacturer. In some tests, a control channel may fall into anti-resonance, where its signal drops to nearly zero. And if the system continues to use this channel in the control average, it will artificially increase the drive voltage to compensate the channel's values. And open channels solve this problem. When a control channel drops below a defined threshold, for example 10 millivolt, the system automatically detects this and removes it from the control loop. The average is then recalculated using only the remaining active channels. The maximum number of channels that can become open is the total number of control channels minus one. This is really important. It ensures at least one channel always remains in control. Um, so here you can set the limit of open channels, for example, 10 millivolt, a number of open channels. So we have 3 control channels, and the number of open channels will be 2. Another useful feature is signal filtering in shock testing. So let's open shock test. and it is very simple to set up. Uh, for so let's open it. So we go to the channels tab, um, and here we can choose filter. So it is already chosen. Why do we need it? Well, in shock testing, high frequency signals often get mixed with unwanted noise, for example, a high frequency ringing from the structure itself. And as a result, the shock draft becomes noisy and difficult to interpret accurately. And filtering solve this. We cut off frequencies above a set limit and get a clean, informative shock pulse waveform. So now let's go back to the presentation and discuss the points we have discussed today.
Yeah, so today we've covered multi-channel control and what it requires, and we also gave you an overview of our brand new tool for this application, RL-C25M, massive data acquisition and vibration control system comprising up to 1024 input channels. And we also covered a few real case studies of how this kind of testing and data acquisition can be applied and was applied with rural clients. Before it was RLC25, but we're hoping that RLC25M will be of interest. So we're urging you to send your requests, your projects, and we'll be happy to guide you through multi-channel control and select the best instrument for that among the Rula vibration testing controller line. Thank you very much for your attention and thank you for being here. We hope that was useful, and we will also follow up with the webinar recording because we have heard that there were some issues with the sound. Um, anyway, we're hoping to be able to answer your questions if there are any left. So please also feel free to contact us with any questions, feedback, concerns. We always welcome your feedback and your reviews. Thank you very much and have a nice day.